Bismillahirrahmanirrahim. We continue our discussion with practical examples, and in today's lecture we are going to discuss practical example of virtual memory management. We have already discussed the chapter in chapter 7. In today's discussion we are going to recapitulate paging. Paging is a technique in virtual memory management as we have already discussed it in chapter 7. Next we will see how we can code paging and its sample output. Let's start discussion with recapitulating the topic paging. What is paging? Let's recapitulate this topic as we have discussed it already in chapter 7. When main memory is divided in equal fixed size partitions, where partitions are kept in small sizes. So in order for processes to be stored in them, it is required that processes should also be divided in equal size of chunks, and every chunk is known as a page. As you notice, all pages of your books are of same sizes. Similarly, all pages of a process are also of same sizes. These pages are then loaded in available memory partitions, and every partition is then known as a frame. So, when a page is loaded in available memory partition, so every partition is then known as a frame or a page frame. One page resides in one memory frame. Hence, if a free frame is not available in sequence, so different pages of a single process may also not be stored in sequence. Wherever a free frame is available, a page gets loaded in it, and all the pages of a process are not in sequence or contiguous or one after another. So it is not required that all pages of a single process must be stored in sequence. Wherever a free partition is available in main memory, a page of a process is loaded there. So as a result, different pages of a single process may not be in sequence while storing in main memory. This is what all we have already discussed in chapter 7. So this was just a recapitulation of the topic. Now let's proceed to see how we can code paging. This is a code snippet on how to code paging using any programming language. This is a small snippet. The complete code can be found in Word document attached on your KCMS. In this sample code, we are going to enter different pages and also different sizes of pages. So at the end, you will find pages of different sizes in main memory. So what is the output of this code? So this is the sample output. The code would require you to enter the number of pages per process. So you will have to enter how many pages you are going to provide for a single page, for a single process. You will also require to enter size of the page. So all the pages must be then of that particular size. At the end, the code will generate the addresses provided for all the pages. Remember, those addresses would be the logical addresses. They would not be the actual physical addresses. So you will get on the screen the logical addresses of different pages of single process. That is all for now. I thank you all.